In 2018, the IPCC published a report saying that we need to limit global temperature rise to 1.5 degrees Celsius by 2030. 1.5 degrees Celsius may not sound like a big deal, but we're already at about a 1 degree Celsius temperature rise since pre-industrial levels. So we definitely want to change our current warming rate because it's way too high. If we don't meet this goal, we'll see irreversible effects of climate change like more severe heat waves, sea level rise, flooding, species loss, food shortages, and among many other things. So it's a big problem. This means we'll need to make major changes like switching from fossil fuels to sources of clean, renewable energy and reducing food waste in order to reduce emissions. So how in the world are we supposed to do this, and are there any cool ways to do it? One innovative way is through anaerobic digestion. Anaerobic what? Anaerobic digestion. Anaerobic, as in occurring in the absence of free oxygen, and digestion, as in breaking up big things into smaller, not so big things. So, anaerobic digestion is the process by which microorganisms like bacteria break down organic matter, like animal and food waste. This occurs in an oxygen-free tank called an anaerobic digester. The bacteria ends up converting waste into biogas, which is mainly methane and carbon dioxide. Biogas is a renewable source of energy and a clean alternative to fossil fuels because of its lower carbon content. Plus, biogas plants capture methane that would have escaped into the atmosphere. And we wouldn't want that because that leads to bigger greenhouse gas effects. So how does this magical anaerobic digestion thing work? Well, it's basically done through 4 main steps: hydrolysis, acetogenesis, and methanogenesis. You're probably wondering, what in the world does that mean? But don't worry, it's not that bad, I promise. Basically, first, organic polymers like carbohydrates need to get broken down into sugars and amino acids, and this is a hydrolysis. Then, acetogenic bacteria come in to convert these into carbon dioxide, hydrogen, ammonia, and organic acids. Then, acetogenic bacteria do the same thing with organic acids, so we're just left with carbon dioxide, hydrogen, ammonia, and also acetic acid. Finally, methanogens convert all of this to methane and carbon dioxide. So what does this matter for us? Well, we get to use the biogas for really cool stuff, like using it for electricity, heating and cooling our houses, and fueling our vehicles, all while keeping our planet cleaner and reducing our emissions.